Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Generative Adversarial Networks. GANs. AI's creative rivalry for realistic creations. Have you ever wondered how a computer could create something brand new and realistic? Instead of just recognizing patterns or answering questions. That's where Generative Adversarial Networks, or GANs, come in. Imagine a master art forger trying to create paintings so perfect they fool an expert art detective. The forger gets better by learning what the detective catches. And the detective gets better by seeing more sophisticated fakes. This constant rivalry makes both incredibly good. As developers, we're used to programming explicit rules. GANs are different. They learn to create without explicit instructions. Which is revolutionary. Think about automatically generating realistic images, sounds, or even new product designs. That's the powerful capability we're talking about. At the heart of every GAN are two separate, competing AI models, often called neural networks, which we'll explore in other lessons. 1. The generator. This is our art forger. Its job is to create new, fake data, like an image, that looks as real as possible. It starts with random noise, like a blank canvas or just random thoughts, and tries to turn it into something convincing. 2. The discriminator. This is our art detective. Its job is to look at data and decide if it's real. From a dataset of actual photos, or fake, created by the generator. It's a binary classifier. It just says real or fake. From a developer's perspective, each of these is essentially a separate program, coded to have specific inputs and outputs. They learn through experience, much like a human trying to master a skill. How do these two programs get so good? Through a continuous, high-stakes game of cat and mouse. 1. The generator creates a batch of fake images. 2. The discriminator is shown a mix of real images from a genuine dataset, and these fake images. 3. The discriminator tries its best to guess which are real and which are fake. 4. Based on the discriminator's guesses, both networks get feedback. The discriminator learns to be better at telling real from fake. The generator learns how to make fakes that are more likely to fool the discriminator. It's like a student, generator, trying to pass a test set by a teacher. Discriminator. The teacher gets better at spotting errors, and the student gets better at avoiding them. This isn't just a simple if-else statement. It's an iterative process where the internal parameters of both neural networks are constantly adjusted based on their performance against each other, creating a dynamic, self-improving system. Let's dive deeper into the generator's role. What does it start with? It typically receives a vector of random numbers, often called latent space or just noise. Think of it as a set of random instructions or a seed. For an idea, the generator then takes this random input and, through its complex internal layers, like a series of mathematical functions, transforms it. It's like a sculptor starting with a block of clay and shaping it into a recognizable form. The output is a brand new, unique piece of data, an image, a sound clip, a piece of text that hopefully looks very convincing. From a coding standpoint, the generator is a function that maps a low-dimensional random vector, e.g., 0.1, minus 0.5, 1.2, to a high-dimensional output, e.g., an array representing an image's pixels. Its internal structure dictates how it performs this transformation, and training is all about optimizing this mapping. Now for the discriminator. Its job is to be the ultimate fact-checker. It receives two kinds of input. 1. Real data, actual images from our training dataset, which are guaranteed to be authentic. 2. Fake data, Asterisk images generated by the generator, which are trying to pass as real. The discriminator analyzes each input and tries to determine its authenticity. It's like a security guard checking is this person legitimate? Or are they trying to sneak in? Its output is typically a probability score, usually between 0 and 1. A score close to 1 means very likely real, and a score close to 0 means very likely fake. As a developer, you can think of the discriminator as a classification model. If you've ever built a program to categorize emails as spam or not spam, this is conceptually similar. Its job is to output a single value, a probability, based on a complex input, an image. Its learning improves its ability to correctly assign these probabilities. Let's put the generator and discriminator's interaction into a full training loop. 1. Generator creates fakes. The generator takes its random noise input and produces some new data, e.g., a batch of fake images. 2. Discriminator evaluates. The discriminator then gets a mix of these fakes and some real data. It processes both and tries to distinguish between them, giving a real or fake probability for each. 3. Discriminator learns. Asterisk if the discriminator makes a mistake, e.g., calls a fake image real, or a real image fake, it adjusts its internal settings to get better at its job. It wants to be a perfect detective. 4. Generator learns. The generator then gets feedback based on how well it fooled the discriminator. If its fakes were easily spotted, it adjusts its own settings to try and make more convincing fakes next time. It wants to be a perfect forger. This cycle repeats thousands, even millions of times. Both networks continuously push each other to improve, leading to astonishingly realistic and creative outputs from the generator. This entire process is orchestrated through a training script you'd write, defining the network's data flow, error calculation, and parameter updates. So, what incredible things can we do with this creative rivalry? GANs are behind some of the most exciting advancements in AI. Generating realistic images. Asterisk creating faces of people who don't exist. Like, this person does not exist. Landscapes, animals, and more. All from scratch. Image-to-image translation. Asterisk transforming sketches into realistic photos. Changing day scenes to night. Or even stylizing images. E.g., turning a photo into a painting. Data augmentation. For tasks where real training data is scarce, GANs can generate more realistic synthetic examples to improve other AI models. Super resolution. Asterisk taking a low-resolution image and intelligently filling in the missing details to make it high resolution. Art and design. Asterisk helping artists create new styles, generating unique textures, or even assisting in the design of new fashion items or architectural concepts. As developers, this means we can build applications that generate unique content on demand, enhance existing media, or even create synthetic datasets for testing and training. The possibilities for innovative software are immense and continue to grow. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.